to the second talk of week 8. So today we have our first talk from the more cognitive science type perspective. So we've been talking a lot about, thinking about safety and agents and robustness with respect to disturbances and thinking of that in terms of a kind of a game theoretic setup. And I mentioned a bit about how we can go, beyond our bubble within engineering and see how other people are approaching kind of similar types of problems. So today we have Robert Hawkins. Robert did his PhD in psychology at Stanford, and then now is at Princeton at their Princeton Neuroscience Institute as a postdoc, though I believe he's physically located here in San Diego.
Yes.
And yes, and he's looking at and studying, the kind of game theoretic aspects about how agents communicate and work with each other, but from, studying the cognitive science side of how humans do this. So like the social interaction and how humans like communicate in like an efficient and flexible type of way. And so he has very graciously offered to give us our first presentation kind of as a foray into cognitive models of human decision making. So with that, I will turn this over to Robert. Thank you so much.
Yeah, thank you so much, Sylvia. Yeah, it's really nice to be here with all of you. And yeah, I'd really like this to be interactive and just as like ambassador from cognitive science. There's a lot of just kind of like unspoken assumptions just about like the way we sort of think about things, and hopefully like these slides are like a good way into that, but I think there's a lot of kind of discourse of going back and forth between the different ways of looking at things that kind of like are best played out through like interactive discussion, which is like maybe one of the takeaways from the research as well. Like a lot of.
So you'd like us to just unmute ourselves and talk if we have questions?
Yeah, that'd be great. Yeah, unless, yeah, just like whatever's worked in the past, I guess. That works for me. Or like if, yeah, Sylvia, you want to like moderate, or I don't know, I'm happy to do whatever. But yeah, please just like shout and interrupt me. Cool. Let me reshare my screen. Cool. So I want to sort of start by kind of posing one of the main problems that I think about, which is how two brains manage to communicate with one another. So, we spend a lot of time, sharing the ideas, experiences, feelings in our own heads with other people. These are complex things. They're not just like signaling A or B. It's like very high dimensional space, right? And from a sort of communicative perspective, we do this in lots of ways. So we can use our vocal cords to make sounds that the other person hears in their ears and understands. We are at our computers typing text that goes in people's eyes and they understand. And sometimes we even like go to our whiteboards, or I guess our iPads over Zoom, if anyone is that fancy, and sketch some diagrams. And all of these actions are intended to be meaningful to other people. But this is such a like narrow bottleneck. And the things we want to talk about are so complex that it's sort of like a really remarkable fact that people are actually able to do this pretty well. So a lot of my work has been about this question of like how we manage to understand each other. So we are able to like emit these signals and, take in these signals and like coordinate roughly what we're thinking. So this is kind of like the hard version of the problem, I think, that comes into play in a lot of aspects of multi-agent systems, right? Anytime you have like multiple agents that need to do stuff, they need to like solve this problem somehow. So from this sort of decision-making aspect in cognitive science, there's kind of two, like, this pendulum keeps swinging back and forth. So like I say people are really good at this, but you know, a lot of people, you know, spend a lot of time arguing that we're actually really bad at this. So like, you know, in one wave of cognitive science, all these books get published, like people are irrational, people suck. But then at the same time, you know, people do all these really impressive things, right? Like apparently we, you know, we play chess, we do all these things. And I would say that like these examples of playing chess are kind of like a little misleading. Like the things that we're actually really good at is like picking up cups and things. Like we're very good at that. So it's like, are people really good or are people really bad? So, you know, these are like kind of a long-standing debate in cognitive science. And I sort of wanted to start by providing a kind of theoretical lens that some people recently have been developing to kind of resolve this apparent paradox of like, you know, we're able to understand each other, but then like we still miscommunicate, right? So like what's going on? Are people like optimal or are people like flawed? So there's this kind of fact of the kind of computational system that human brains are, right? Which is that we have limited compute, right? We don't get the advantage of like running for 3 weeks, you know, on a GPU to like, you know, come up with something. We often have to make like fast decisions under pressure in real time. And we only have like what we come with in terms of like compute. We can't like parallelize across more clusters or whatever. So like, you know, this is kind of like a fundamental constraint on the kind of computations that human brains can do. So this is like often couched in terms of bounded rationality, right? So the kind of classical perspective is like, well, people basically tap out of their resources at some points, and then basically we like do some churning and then we like stop early, and maybe we've stopped early with something kind of like suboptimal. So this is kind of like a classical argument for irrationality. But I think what the really exciting kind of new perspective is this idea of like, maybe even though we're limited, we're pretty good at making good use of the resources we do have. So the idea is that we essentially like find ways of solving problems with the resources we have, and we have control over our use of those resources. So it's not like we're fundamentally limited. We can make decisions about how we deploy those resources. So you can sort of contrast these two kinds of perspectives in like a utility theory framework. So the kind of classical idea is that, you know, we can basically search over the space of all of the things we can do, evaluate some utility function, and pick the right thing to do. So this is like the classic notion of rationality. But the problem is that these utility functions are actually like often expensive to evaluate, and we can't actually practically pick the actual optimal thing. So this view of resource rationality, which was kind of introduced several years back, is that we can estimate for each policy basically like what the value of using that policy would be and what the cost of that policy would be. So this is essentially like shifting the burden, not from doing the right thing, like maximizing the action, but maximizing like a strategy for picking actions that balances our constraints against the benefits of like a particular policy. So the idea is like we're trying to find the optimal trade-off between our limited resources and what we can achieve with them. So one way to sort
So
of
can I ask a question?
Yeah.
Sorry.
You go first, Abel.
Yeah, so it's more like you're not necessarily doing the best thing if it's going to incur for you a very large penalty, right? So you're trying to find that sweet spot where you're balancing the trade-off between benefit and
Yeah,
constraint.
subject to constraints, you could say. Yeah. So it's like the optimal thing subject to constraints.
I have a quick question too. Could you go back one last? So here, A is the action, pi is the strategy, and then what's theta?
So theta you can kind of think of as like I sort of like used my own notation here because it's going to play into an example that I'm going to use later.
Sure.
But basically like I'm thinking of this as kind of like different policies give kind of like different parameters of your utility function a little bit. So the idea is like there are different ways that you can like consider utility, and some of them are more expensive than others. So it's different ways you can act in the world.
But you said you'll go through an example with us.
I want to go through a clear.
Okay, great.
So basically the idea is
Wonderful.
that like there's something about a policy which is costly, but also like shapes the actions you take, and
Right, sure.
that you're kind of trading off. Yeah. So, sorry, confusing notation.
No,
I'm sure it's not the first time you've had confusing notation in slides, but yeah, okay. So yeah, I think this is just kind of a visual depiction of this is, you want to have a strategy for coming up with actions that that is both efficient and leads to good expected outcomes. So yeah, this is sort of like a general perspective that if someone like Tom Griffiths were giving this talk, he would then go through a bunch of sort of results where they found that actually you can derive a lot of things that people previously thought were irrational as optimal uses of limited resources. So it's sort of like, it's the best thing you could possibly do under these constraints. So it's sort of like various things you might consider like heuristics, right? That like you can find edge cases where they're suboptimal. You can actually kind of prove that if you consider certain like cognitive compute limitations, they are actually like optimizing a different problem. So this is kind of like one way of thinking about cognitive science, and sort of like rational approaches to cognitive science is basically like trying to figure out what problem humans are optimizing, right? And it's like the kind of conclusion is that like the thing that economists in the 60s like thought that people ought to optimize isn't the thing people are actually optimizing. People are actually optimizing like a different function, but it's still like rational under that function. So this is kind of like a recent response to like throwing up your hands and saying, we can't possibly understand how humans behave. They just do all these crazy things. It's like, no, actually people are very systematic and we can predict how people act. We just have to like use a different function. So that's sort of like, from the perspective of like designing interactive autonomous machines that can interact with people, this is kind of like, maybe when we want to use a model of people more like the thing on the right than the thing on the left, right? Like if we expect people to maximize utility, we're going to like do the wrong thing when interacting with them. Whereas if we expect them to like trade off cost and utility and like come up with clever solutions that like work for most cases, we may have like a more accurate model that explains how people behave. So that's kind of like the high level sort of philosophy here. And then, yeah, I want to go into a specific example of this from my own research, and then kind of like try to extend this to think about how we can design more adaptive systems, like through online learning. Okay. So I'm not sure in the kind of like game theory context whether you've talked about this idea of theory of mind. Can I get like a thumbs up or thumbs down if this is like a familiar?
Not really, no.
Okay, cool. That's great. So basically, there's this thing that social cognition spends a lot of time thinking about, which is basically like when I, as a human, think about other humans, right? What do I expect? Like, how do I make predictions about them? And the claim of theory of mind is that I'm able to do this by representing their underlying mental states. So basically, I'm not just doing like feed forward frame prediction, like whatever. I'm basically like supposing certain latent properties that are in their heads that explain their behavior. And then I can like infer what those latent things are, which allows me to make better predictions. So it's sort of like, if I know that you believe that like an object is in some location, it kind of doesn't matter whether it's actually in that location or not. If I can like represent what's in like, yeah, the beliefs about the world that are represented in your head as sort of distinct from the true world, and like your particular knowledge and your particular desires, like what your preferences are and things like this. These are like really powerful like variables that account for a lot of downstream behavior, if you kind of assume that people are like pursuing their desires subject to their beliefs and knowledge and whatnot. So there's a big controversy. So basically this like pendulum about irrationality and rationality that keeps swinging back and forth in cognitive science. There's this big controversy that's basically like, in basically 2003, a very prominent study came out basically arguing that people don't have theory of mind or don't use theory of mind. Okay. So this is like a paradox. It's like we're sitting here talking to each other. We're like clearly like, I asked whether you know theory of mind. That's a basic question about like your beliefs. Like, are you like, do you know what the word this means? And like we're sensitive, clearly sensitive to the fact that other people like may have different beliefs than our own. This is like how we give talks. It's how we like do all kinds of, you know, it's like why we write papers and things. But like at the same time, it's like there's this very puzzling finding where they basically ran this experiment where they gave people a big grid of objects, like candles and apples and trucks and things. And they were playing a game where one person is a director and they say words that give instructions for another person to follow and sort of execute in this environment. So you can imagine like if you don't have these occluders, this is a pretty standard like reference game like you might see in like robotics or something, right? Or reinforcement learning where there's some instruction following, right? You're like naming something and then the learner agent has to like go retrieve it. So that you can sort of think of this as like a pretty basic task. But the complicated part in the way that they were trying to probe theory of mind with it was by putting these little dividers over some of the cells. So basically you're in a situation where one person can see stuff and the other person can't see that thing. So the director, unbeknownst to the listener, is actually a Confederate, so they're paid by the experimenter to like do something. So it's like duplicitous, and you know, they purposefully produce an ambiguous utterance. So basically, they say tape, but from the so like from their view, there's only one tape, right? But from the learner's view or the matcher's view, there's actually two tapes, right? There's like a cassette tape and a roll of tape. So like from their view, it's actually ambiguous, right? It could apply to either of these things. But if you are using your theory of mind, you should be able to reason like, oh, the other person can't see this, so they can't possibly be referring to this, right? So that you should be able to like rule out this object and pick this object. But what they found is that actually like a surprising amount of the time, listeners like picked the hidden object, which like seems to be irrational, right? It's like, or at least like egocentric and like perspective blind, right? Like you're violating some very basic like you're clearly not representing what the other person knows about. So this was like made a big splash because it sort of like created this puzzle. Like, how can we simultaneously be so good at reasoning about other people and like fail so catastrophically in such like a simple case? So this is a problem that a lot of people have worked on, and it's kind of like a stand-in for like, you know, this particular task has kind of been a stand-in for questions about like how people actually deploy theory of mind in like day-to-day interactions, right? So it's like people clearly have theory of mind, people can do this, but basically these folks, Boaz Kazar and there's a whole crew, were basically, you know, arguing that because of this like irrationality, we basically like using theory of mind is costly, right? It's like hard, it requires compute, and like people run out of compute at some point and like basically may sort of do this egocentric thing where they like initialize with their own view and then like stop short of accounting for the other person's view. And then maybe only like do it if they have to. So like basically if they make an error and you're like, hey, do it again, they'll like see their mistake, but like aren't going to do this sort of spontaneously.
I have a quick question.
Yeah.
I assume that this was accounted for, but did they consider the fact that young people might not know what cassette tapes are? Like,
yeah, that's a
were there other examples?
It's like the Confederate should obviously like you know, refer to this thing differently if they're talking to a young person or an old person. I mean, they ran the study in 2000, so I don't know. I guess people maybe still knew what cassette tapes were then.
Probably.
Yeah, like my truck had like a cassette player in it at that point, so yeah. Yeah, but I think that that's actually a really, this will get into the second half of the talk, is this kind of reasoning about like who your partner is and like information about different social groups and things like this. So like, yeah, I would argue that like to build systems that are really like sensitive to like variability in the population and can kind of like be understandable to the biggest set of people, you really need some representation of that that kind of variable. Yeah. So that's a really great insight. Yeah, are there other questions just on this like phenomenon, just while we're on it? Cool. So basically this is like clearly like a very like narrow, like lab toy task, right? But like you can kind of imagine how these kinds of things might play out in more realistic, like driving tasks or something, right? It's like you don't know whether another person knows like you're about to make a turn or something, and then like, you know, you kind of, if someone is perspective blind, they may not appropriately take into account like, you know, the actions of other people, right? Like maybe you forget to signal or something, I don't know. Okay, so I kind of want to transition now into like the way that this phenomenon can be understood in a resource rational perspective. Okay, so this was a paper that we put out this year, or I guess last year now, but has sort of been like a cottage industry since 2003. So the first insight is that there's kind of three things that someone needs to track in this setting, right? They need to track what is in the shared view, what do I know about and the other person knows about, what do only I know about, and what are the unknown unknowns, basically, like, or sorry, the known unknowns, like what are the things that like the other person knows about that I don't know about. So you can kind of think of it like this. There's sort of like this pepper, which is like in my view, but not my partner's. There's something that I have no clue what it is. Maybe it's nothing. Maybe it's empty that could be in my partner's view and not mine. And then there's something that I know for a fact that both of us can see. So there's this question of like, how do I, as a speaker, make a decision in this environment, right? How do I pick what to say as a speaker to like refer to a thing? And what do I kind of do as a listener to follow that instruction? So this is kind of like a basic cognitive decision-making process. There's just like two agents and each of them have kind of like a slightly different problem that they're trying to solve. And there's a family of models that may come up later in the course, I'm not sure, that are basically recursive reasoning models. So you can kind of think of these as epistemic game theoretic models, where you're sort of like, you start with some base case, which is someone, it's like a listener agent that's making decisions about which object to pick after hearing an utterance in a particular context, okay? And this equation is basically like, okay, the listener will choose proportionally to the literal meanings of utterances. So basically like, if I say candle, candle is true of this thing and not true of this thing, right? So I have some basic little language semantics in my head, and some sort of prior over objects. So it's basically like, you know, these are the two objects that are like candidates, and I want to like choose proportionally between them based on like how much the utterance I hear applies to them. So if I hear candle, I'm going to pick the candle and not the thing. But if I hear like something that's true of both of them, I might go 50-50, right? So it's basically like, if I just hear object, it's like, okay, this is an object and this is an object. So once I normalize, I'm like, okay, 50% chance of picking this, 50% chance of picking this. So this is sort of like a very basic.
Robert, sorry, quick comment on speaking of views. I don't think we can see your mouse if you're doing stuff with your mouse, just FYI.
Okay, is there a way to like make it so you can? Yeah,
I'm not sure. Does anyone know if you can like how to ensure that in Zoom? I always, if I'm using Keynote, I open it in a window. I view presentation in window.
Nice. Okay.
Instead of full screen.
I see. That would.
Or you can just try to, just gesture verbally for us, just in case you were using your mouse.
I was definitely using my mouse. Okay, maybe I'll try it in window. Let me,
Oh wait, oh, okay, yeah.
I just like took that out.
Yeah, I think if you go to, it's like view or percent at the top.
Okay. View. Gosh, this makes me
Or
wonder.
no, it's in play. It's under play and then play slideshow in window at the very top.
Nice. Okay.
And then you can full screen the window.
And
then now, yeah, now you can see your.
Oh my gosh, that's such a good hack. Thank you.
Sorry for the interruption.
Well, this is like, I've probably given like a dozen talks where I've been like moving my mouse and probably no one. So it's like, that's clearly a blind spot. Theory of mind. If no one tells you, right, there's no way you can know. It's from your perspective. Right. So, okay, I was just telling you about this L0 agent. And then the basic idea of these models is like, okay, I'm a speaker. What should I do? I'm trying to pick an utterance that will be helpful to my partner. So my decision making is kind of contingent on what I think my partner is going to do. And there's a particular object I would like my partner to pick, right? So say that I'm like, I mean, this example is terrible because this was just to demonstrate the different kinds of objects, but like think about this kind of case where there's like lots of objects. So basically I have a little utility function that's like, I should pick utterances proportional to the utterance cost of them. So like maybe giving some like long-winded, excessively detailed, description of like every little aspect of the object is like a little over the top. But I would like to maximize the probability that my partner picks the object that I want them to. So basically I think about like, okay, what would my partner do if I said this utterance? And what is the kind of surprisal, you could say, of like picking the object that I want them to. So basically like I'm going to prefer utterances that balance this trade-off of the cost of producing an utterance and this expected success of my partner's action after saying this utterance. And this is just the softmax parameter. So this equation is already a little bit of a flavor of resource rationality, although this isn't going to be like the main like place where that becomes interesting. So this is basically like, you can think of a speaker as trying to like balance parsimony and informativity in this case. And then you can build a listener on top of the speaker that's basically like, I want to pick proportionally to like what I think a speaker would be referring to by picking an utterance. So this is basically like inverting this speaker model as a listener. So I'm sort of like, objects that would make the listener say a particular utterance, I'm going to be more likely to pick, and utterances that are less likely to make a speaker say an utterance, I'm less likely to pick. So this is a little sort of like recursive tower. And in principle, you can keep building agents on top of this, right? It's like a kind of recursive chain of reasoning where sort of each agent is like best responding to the previous agent. So you can kind of, this is sort of an alternative formulation to the game theoretic way of thinking of this. That's sort of like more in terms of like one agent reasoning about another agent's beliefs kind of explicitly, as opposed to thinking about like equilibria or sort of fictitious play. Yeah. Okay, so this is like a well-studied model, but it doesn't have any perspective taking in it. So this is basically like how you deal with situations where everything is visible to everybody. So one thing we did in this paper was to kind of introduce a mechanism for perspective taking. So basically, we can define a speaker that's egocentric and only chooses between objects in the visible context, or yeah, basically is like only considering referring to an object in the context that's visible to them personally. And then what we might call like an asymmetric speaker that like reasons about the fact that the listener can see things that they can't. So they basically are like gonna marginalize over the possible things that could be behind that occlusion. And then say that, okay, our speaker is a mixture of these two things. So it's like they kind of trade off being egocentric against being like theory of mind based. And then similarly, like a listener is like, can either choose egocentrically, so basically like only think about a speaker that sees the same things they see, or they can consider the fact that the speaker can't see some things. And then the kind of resource rationality move here is, so this is the equation from Tom Griffith's paper, where basically we have a resource rational utility, RR, that allows the speaker to choose what weights they should put on perspective taking. Okay, so the basic concept here is like, I'm a speaker and there are costs and benefits of weighing my partner's perspective. So the costs is that like perspective taking might be effortful, right? Like I may need to use some of my resources to really like churn that out, think about it. But it has some benefits, right? So when I take my partner's perspective into account more, I may have a higher expected value of communicative success. And similarly, the listener is like, okay, taking my own perspective or taking my partner's perspective is costly, but like if I use a higher thing, I like am more likely to pick the right objects and not like make one of these errors. And importantly, this is sort of like depends on what weight you think your partner is using. So this is a division of labor in communication. So basically it's like, if I think my partner is going to perfectly do perspective taking, I kind of don't have to, right? Because like they're already going to like solve all the problems for me, right? And vice versa, if I think my partner is like going to be completely egocentric, more of the burden shifts to me to like use basically in order to like achieve the same expected accuracy of the interaction, I need to like use more of my juice to like get us there. So this kind of creates this like interdependence between my perspective taking and your perspective taking, which is like these previous models of either just like completely egocentric, like perspective taking where it's not really under my control. I just like am fundamentally capped at some level of juice I can use, and I use up to that amount of juice and then I stop. So that's kind of the like irrational classic model, or the full irrational model, which is like, I basically don't have this consideration and I just want to like fully optimize my expected utility. So you can show in simulations that we then tested in behavioral experiments that you basically get these curves where different amounts of perspective taking are optimal depending on the cost of perspective taking. So this is that beta here. So it's basically like in an environment where there's like a big cost on a higher weight. So like tuning up my perspective taking by like 50% like leads to a cost of like, you know, a lot versus like tuning it up by 50% only leads to like a marginal cost. So that's these different colors. And basically what you see is that in these low cost settings where basically there's no, basically when beta is 0, you just get rid of this term and you're back to your classical rationality accounts. Basically, I should always use more perspective taking. Basically, the optimal amount of perspective taking is 100% perspective taking, right? I should always completely use my partner's perspective. But as the cost starts going up, I start shifting to where it's like more optimal to use intermediate levels of perspective taking. So I sort of like mix in some of my partner's perspective, but like not that much, right? So it's sort of like this kind of like gets you partway there, but you still have some biases from your own perception. And then when it gets like really expensive, you're down to like very low levels of perspective taking. So it's sort of like, this is maybe more of the egocentric kind of case where it's sort of like so costly to take, it's just not worth it. Like the benefits of communication are just like, don't pay off. And similarly for the speaker, when you don't have any cost of perspective taking, you might as well just like use as much as possible because it like gets a higher accuracy. And then as the cost gets higher, you sort of like slack off more. So you sort of like end up with sort of these more moderate levels. Okay, so this was kind of like a somewhat complicated exercise. There are a lot of layers of like this recursion and then the parameter, but the kind of takeaway here is that this kind of model, unlike classical models, accounts for a lot of the range of behavior that we see. So the idea is like in some environments where people are under what psychologists call cognitive load, right? So like if it's a very high stress situation, if you have to like be juggling lots of things at the same time, right? Like suppose you're like driving and you're like on the phone and you're like, listening to music and you're doing all these things, you're like, it's not like one way to think of it is that you're just like distracted, but another way is to think that you like have fewer cognitive resources available to like do other things, right? So if like your quote unquote limited capacity, which is a thing psychologists care about a lot, is like, what is capacity? Like, what is the notion of capacity? This basically predicts like you'll scale the amount of perspective taking you do to sort of be like rational under the constraints that you're under. So it's basically like you'll use the appropriate amount of perspective taking to like get the value you want under constraints. So, it also predicts that if it's a high stakes situation where like, you really have to get the decision right because it's like you could lose a lot of money or your life, right? It predicts that you would take the cost, right? So it's like basically it would be worth it to incur a large amount of effort because it like you need the payoff so much. So basically the idea here is that like effort or this kind of notion of these constraints aren't like fixed, right? They're like things that you weight in your decision making, and like different aspects of the situation can lead you to weight them more or less. And the one last kind of thing I'd like to highlight in this section is that, and which kind of segues, I think, into what I want to talk about the rest of the time, is that it's adaptive. It's inherently adaptive because the amount of effort that it's worth it for you to incur can depend on other aspects of the context. So this is another simulation. So like one observation we made in this game is that people make fewer errors over time. So like basically after you've played this game for like 15 minutes, you just aren't making errors anymore. So basically all of these errors they observed where like you were picking the hidden objects were like very early on in the task. So it's like either like perspective taking just stops being costly, which is like a weird argument for the like people are irrational like thing to make, because it's like, you know, if something is costly, it's costly under that perspective. But what we can see is actually like, as you interact with a partner that's like not cooperative. So suppose you're playing a game where the speaker is just like keeps saying really underinformative things that are like confusing, right? And keeps leading you astray. Over time, you're like, okay, my partner is clearly not doing any perspective taking. So like, in order to succeed at this task, I guess I'm going to have to crank up my own perspective taking. So actually what you find is that the optimum, like basically these curves, shift over time as you observe the way your partner is acting. So because this first term depends on the context, the benefits of different levels of perspective taking, of different levels of effort, scale as a function of your learning. So like, as you spend more time in this environment, different things become optimal. So basically we find that like the optimal weighting actually goes up over time as you infer what your partner is doing. So this kind of explains why people adapt the level of effort that they use in a task over time, which is also something that kind of like classical accounts of rationality can't predict. So in some ways, this is like more rational in the sense that it's sort of like taking into account what is needed in the situation and changing the amount of effort to achieve that. Okay, so let's talk about this.
Yeah, I have a question. So I think I can kind of get behind the model where you have none at all, and the one where you're like trying to do your full effort on figuring out their beliefs. As an example of where you're only like partially reconstructing their beliefs, are you essentially just using like a really coarse model of trying to predict what that is, and then you refine it over time? Or do you think there are like discrete different ways in which you are processing their beliefs?
Yeah, that's a good question. So I think this is where people of my persuasion often appeal to someone named David Marr. So David Marr was a vision scientist at MIT and wrote a very nice book called Vision. And the introduction to that vision kind of outlined these different levels of analysis that you can make models at. So the highest level is this quote unquote computational level. And then underneath that is like an algorithmic level. And then underneath that is an implementational level. So you can kind of think like in engineering, there's sort of different steps of solving a problem. One is just like specifying the objective function. And then another one is sort of like saying what actual algorithm you're going to use to optimize the objective function. And then below that is sort of like, how do I actually code that in like a particular language or something, right? Like, or run it on a GPU versus a CPU, or like these kind of like more like low level decisions. And this is sort of posed as a computational model. So this mixture model is essentially saying like people are weighing multiple constraints, right? So it's like, and kind of integrate them simultaneously. So it's sort of like a view where you're kind of like you're getting like two signals coming in. Like one is the egocentric signal and one is the kind of perspective taking signal, and you're kind of like paying more attention to one than the other or something, right? So
okay, so for example, in the experiment that you had laid out for us, I could see in the case where the weighting is on one extreme, the person just grabs the immediate thing that comes to mind. On the other extreme, they're reasoning out every single possible location that they haven't seen yet. How would you, as the person who's like observing this, like what would you expect to see for someone who's only weighting it partially?
yeah, it's kind of interpolating basically between the two. So it's sort of like the behavior is, I mean, partly it's a probabilistic model. So the mixture can kind of come out like as a, like, sometimes you do the more egocentric thing and sometimes you do the more, you know, perspective takey thing. You're just kind of like noisy, right?
Mm-hmm.
And it can also come out as sort of like, there are maybe some, so like the way that this plays out in practice is that when you're a speaker who's taking into account the listener's perspective, you use longer, more informative utterances. So instead of saying move the tape, you might say like move the clear cassette tape with a, you know, that's like has a Leonard Skinner like album cover on it, up one thing. So it's like basically, even though it's like there's only one tape in your view, you just like give more details, right?
Sure.
So that's something you can kind of see how you might interpolate, where you might like mention the color of it, which is a little bit over informative, but not kind of like really
Right.
out of like, yeah.
Cool. Thank you.
And actually, in the task that I'm not going to share with you because I figured the model is more interesting, we actually test this so you can manipulate whether there are occlusions or not. So basically, you put a speaker in a setting where basically they see exactly the same object, but some of the other ones are covered, and you get this massive effect where they use like lots more words when things are hidden. So like this is very clear evidence of theory of mind on the part of the speaker, right? Because like there's no reason from their own view that the occlusions should matter at all, right?
Right.
So that was kind of a nice finding that, okay, speakers are doing something here. And then, you know, it's like there's clearly a scale. Yeah, okay, that's enough.
Yeah, sure. Yeah, I understand. Thank you. That's interesting.
But I do think that the question of like pushing that down to an algorithmic level, to kind of return to your first point, is like, I think probably the next step that needs to be worked on. So there's lots of different kind of more incremental views. So like actually a lot of the, so like the idea of like refining, right? Like starting with a course define kind of process where you like have, you know, basically like you go from this really sharp thing of like people either see it or don't see it. And then it's just this really sharp, like you either tip into this one or tip into this other box, versus kind of like making a finer partition of the scale or something. I think that that's like a really interesting hypothesis that you could try to think of a way to test, where it's sort of like, yeah. So I should say that a lot of the experimental evidence in this literature has come from eye tracking, which is a technique that is often used in these kinds of studies, where you put a little machine on someone's head that tracks where they're looking in a display. And you can actually see like in these kinds of situations, like how often are they even like looking at this, right? Which is sort of like, even if they don't pick it, like how much are they like thinking about it?
Yeah.
So it's supposed to be like a window into like how early are they resolving this, right? So like you can sort of see these curves where it's like they start looking at it early on and then they kind of rule it out, which is kind of like meant to support certain more incremental models of like,
Cool.
you know, yeah, how they're refining the hypothesis space or whatever over time. But basically these models don't predict time courses, right? They're sort of about the outcome of the thing. So basically in order to get these models to predict why you would like change what you're looking at over time or something, you would need to push it to like a more stochastic process kind of thing, or like a more dynamical Kalman filter thing or something. Are there any other questions about this kind of particular setting, thoughts about how it kind of ties into other problems that you've been thinking about in earlier in earlier lectures, or this kind of general perspective of like humans being limited, but in kind of a systematic, predictable way, as opposed to like a irrational way.
Can you, I have a question. Can you
Yeah.
talk a little bit more when the weight is 0.5? Like, what was the situation when it's kind of like balanced for both speaker and listener?
Yeah. That's a great question. So basically, there's like, in principle, a whole continuum of like equally optimal solutions, right? Where it's like me doing 100% of the work, you doing 0% of the work. And then kind of like, you can see the kind of like Pareto curve or whatever, where it's kind of like, we both don't need to be doing 100% of the work unless we're like in, you know, this territory where it's basically cost free. And then the like, you can kind of imagine the curve being like basically like a box where it's like basically both of us using 100% is like as easy as using less. But like as you crank up the cost, yeah, there becomes this like frontier, right? Of like optimality, of like joint to optimality. And then I think so like that's basically the theoretical picture, is that there's in principle kind of a symmetry between all of these things. But I think that there's various questions about how that symmetry might be broken by like other asymmetries, right? So like in the relationship between the people, in the capacities of the people, right? Like if one person has like a higher beta than the other person, which is not an unrealistic expectation, if someone is like more cognitively impaired because of like how they're, I don't know, like in a car, maybe like the listener or like the person in the passenger seats is like under less cognitive load because like they're not having to like be watching the road, so they could like take on more of the conversation or something, and maybe like do more work in like noticing other things in the environment or whatever, right? So you could imagine these kinds of situations where you kind of divvy up work asymmetrically, and then that sort of relies on the person, each person kind of like being able to either know ahead of time or infer through the situation like what their partner is doing. So that's kind of the adaptation example, right? So it's like, this is basically like they started with an expectation that their partner would be kind of like equally able to deploy any amount of work, but then kind of like found that in practice their partner was sort of dropping the ball, right? And then kind of adapting to that over time to kind of like go up from 50-60% up to like 90%. So I think that that's kind of like how I've been thinking about these weights, at least like at a high level. Does that answer your question?
Yeah, that's very cool.
Thanks.
Oh, I had a question in regard to like the experiment design. So when you like in that tape experiment, how did you guys was there any experimentation with like changing the coefficients and stuff like that? And how did you guys do that in practice?
That's a great, yeah. So that's something that we didn't do, but wanted to. So this is like, it was already kind of a long paper. So we decided, this is kind of like a thing about publishing in like CogSci journals maybe, is that like they tend to be long, like longer than, you know, engineering paper or like conference papers. So yeah, we already had like a big model and a bunch of simulations and then like 2 other experiments. And so we decided like, oh, we'll leave that for later. But, and then you like write about in your discussion, right? But I think that in principle, this Lin et al. Paper is a good one to look at for that. So they did a manipulation that I think from our modeling perspective, we would consider a beta manipulation. So basically they had participants do another task in parallel. So basically like rehearsing some like words to memorize or something like that, which are sort of known to be cognitive load manipulations. It's like requires some amount of effort to like maintain working memory of something. So like imagine yourself like you're, I don't know, you see a phone number, and then like while you're switching over to the other page on your phone to like enter it in, you're kind of like rehearsing it to yourself. You're like, okay, 217. So like, yeah, I think that that's kind of like one traditional way that psychologists do that manipulation. And they basically found in this paper that people like make more errors when they're under more cognitive load, which to me is like a good like evidence for a resource rational perspective that like basically people in these other camps like Heller, who is a person that previously worked with a model kind of like this for this task, was kind of unable to explain like why would, so basically this Daphne Heller, she's at Toronto, she did a lot of nice work kind of showing that an intermediate weight predicted behavior well, but sort of was unable to explain where that weight came from. So basically they just like fit a weight to data. So they collected a bunch of people playing these games and basically were like, which weight best explains what people are doing? And they're like, oh, like 0.6. But then it sort of like leaves open this question of like, why 0.6? Why not 1? Right? Like, and also like, why would different aspects of the task push that around? Like they could sort of like model that and be like, okay, we did this manipulation and then did our data analysis and it looks like it's more like 0.8 here. And then sort of just empirically say that, but this is sort of like a deeper principle that like derives that like variation. Yeah. Any other thoughts, questions? Give it a few more seconds. Okay, cool. How are we doing on time? Like,
This ends at 1:50, though sometimes students stay a little late to ask questions, but
cool.
They're allowed to leave at 1:50.
Cool. All right, so I sort of wanted to give you this like resource rationality perspective because I think it's like an exciting new way that cognitive science is thinking about decision making. So like, you know, when you're thinking about, you know, how to make engineer systems that interact with people and you want a user model, maybe think about this kind of user model and not like a purely rational one or like non-constrained rational one, but also don't let people tell you that people are irrational because that's wrong. So that's basically like, that's my quick summary of like how I hope that that will be applicable to you, is that like you shouldn't just throw up your hands and say there's no way that we can account for what people are going to do with a system. People do crazy stuff and there's no way to predict it. It's like, no, you can predict it. You just have to have the right model. So like, yeah. Okay. The second part that I guess I'll try to do in like 15 minutes is sort of carrying forward that idea to basically how do we like adapt to people? So everyone is different. There's a lot of individual variability. And also, so, okay, I kind of took out 2 slides here, but I'm gonna put them back in. Because I think they're useful for motivating this problem. So if we want to design systems, so I've been thinking a lot about like language models that can interact with people in a less rigid way in like machine learning. So, you know, static language models have a bunch of problems. They basically are just these monolithic models that use the same language for everything. Like every word, right, is just like, this is what it is. But like, I think that there are kind of two motivations from cognitive science that make that problematic. The first is variability. So this is an article from Grantland that basically like, everybody is going to get these examples of variability from different places, but for me, like baseball really does it for me. So like I start reading this article and it's like, you know, grooving first inning pitches, pitching around, like what does it mean to pitch around things? What is a like four seamer? There's some like number over here. I'm going to put it back in my window. Right. I don't know what I don't know what this number is. So, you know, it's like this article is technically written in English, but, you know, it doesn't mean that like everyone who speaks English understands it. So I think that this is like something that we need to take into account. A second thing is like we live in a non-stationary world, right? Like this kind of environment is really pervasive. So like, you know, lexicographers have been trying for a long time. This is from 1888, like the first edition of the OED, Oxford English Dictionary. And they definitely couldn't have like, you know, when they were kind of documenting what the words are that like every self-respecting English speaker ought to know, they definitely couldn't have anticipated like all the things that we talk about today, like the internet and Googling things, and definitely not like any of the research problems you're working on, like any of you are working on, because they didn't exist back then. So like literally every algorithm, you know, every technique, you know, everything you know about computers didn't exist, right? So like if you write down any fixed sort of model of like how people use language, it's going to be outdated like immediately. So like this was another example that I find compelling. So it's like, you know, I don't know if you see these things or used to see these things around campus, but I really liked this Wired article where they were sort of like puzzling about like, you know, on the internet, it was called a two-wheel smart self-balancing scooters, drifting board, electric blue. So, you know, that's Amazon's referring expression for it. And they're like, it's kind of like a segue because it's like, you know, has these balancing things like, but, you know, it's like a sideways skateboard. People have decided to call it a hoverboard, but like, I don't know why. That's like not really a good name. So yeah, basically like we're constantly having to renegotiate these things. And, you know, from the perspective of like an engineer, Siri is like terrible at this, right? We basically like, you can't use a new word, right? It's like very limited. So a lot of my work recently has been thinking about a more adaptive view of how people work, which is basically like they don't sort of have like a fixed language model that they use. So like it's not BERT, right? They have sort of like a best guess that they use at a particular point in time with uncertainty over whether that will work or be good. And then they do online learning to adapt the way they use language to their partner and the situation. This is a slide from a longer talk. I'm not going to talk about all these things, but basically like the issue is like, okay, we have an individual mind, right? That's doing this theory of mind thing, maybe resource rational theory of mind thing, when they're interacting with a partner, but then they're embedded in a bigger community that sort of has conventions, right? And then these are kind of embedded in larger groups. So this is kind of like going back to Sylvia's points about, you know, demographics mattering, like the way you talk to your grandfather being different than the way you talk to a child or your friend, or like the way you talk at a conference is like different than the way you talk in like meetings with your advisor and so forth. So it's like, basically we like no single model of language can account for all of these things. And a problem, I think, in engineering is how to kind of like understand the way people adapt so that we can adapt to people. So maybe I'll skip this. This is basically like a cool way that psycholinguistics has studied how people talk to each other, and I found it very useful in my work. So it's basically like, it's called a reference game. So it's kind of like that thing with the cubby holes and the grids, in the sense that like you have a big set of objects and there's a speaker and they're trying to like refer to these objects so that the other person can pick them. But the difference is, one, there's not occluders, so no theory of mind problems, at least from like visual perspective. And two, these are ambiguous objects, right? So it's not like candle, car, these aren't things that you like interact with on a daily basis. They're kind of like new things. They're more like those Segway, scooter, hoverboard thing, right? So the task is, so we collected a big corpus of people playing this task that you can check out if you want. It's open. But basically, like, the interesting thing is that people change the way they talk over time. So even in the course of like a 5-minute conversation. So the first time this guy pops up, they say it's like a guy who looks like one of those wavy tube guys leaning toward the left, right? And you can kind of see it. But then like they talk about some other objects, and then eventually they come back to this one. So this is why it's called a repeated reference game, is that the same targets pop up multiple times. And the second time, speakers will say just the wavy tube guy, right? And then at the end, they're just like the wavy man. And like the semantics of wavy at the end are very different than they were at the beginning, right? This guy is not wavy, you know, like in the colloquial sense, right? Like if you asked a person on the street, like, is this a wavy man? People would be like, I don't know, maybe not. But like here you say wavy man and your partner just immediately knows what you're talking about. So this is a form often talked about it in terms of common ground is one word for it. So it's sort of like the shared history that a particular group of people build up over time that kind of like is context for what they're doing. So you're not sort of like interacting with someone de novo every time. You sort of have like a little like amount of history that you can look back at and like refer back to. And it's kind of crazy. Like people say all kinds of different things. So this is why I'm really interested in conventions, social conventions, because they're really arbitrary in a lot of cases, right? So like these are all really stable things that different pairs coordinated on and like used multiple times. And if you ask them at the end, what do you call this? They'd be like, oh yeah, that's a choir singer. Whereas like a different group at the end, you'd say like, what is this? And they'd say, oh, it's the flying guy, right? And these are kind of incompatible labels, right? They're just like, these are just different language models, basically, that people are like converging on in like 5 minutes. And like they get more efficient over time. So like as they talk more, they get away with like way shorter descriptions. And then they're really sensitive to feedback. So like if their partner is getting them wrong, they like won't shorten as much. They'll like try some new things. But if their partner is getting them right, that's sort of like when they do like this kind of thing, right? So this is just like super cool to me. And I just like in the last couple minutes, I kind of wanted to just like gesture at a way that I've been, I think, understanding this as a meta learning problem, where basically you're using your cognitive model of a speaker. You just have uncertainty about the latent thing in their head, right? So you say like, okay, my partner has some way of referring to this that's going to be understandable to them, but I don't know what it is ahead of time. So as I interact with them, I basically do some online learning where I gradually kind of take steps in their direction to like explain what they did better. So that's kind of like my partner specific common ground. But then there's this step at the end that's known as, well, you can either form it in like a hierarchical type model where there's something at the top that you assume everyone is drawn from, every partner is drawn from. And these are sort of like your conventions. These are the things that you extend to new partners. Whereas like these are kind of like local models. So you can kind of think of this as like domain adaptation or like continual online learning for this kind of domain shift problem. But like, I think that the reason I kind of wanted to highlight this in a CogSci talk is that we're kind of like increasingly getting evidence that people are doing something like this. And if we want to interact with people in an efficient way, we can't just use like a game theory model, right? At least in my view, because it's sort of like very much under constrains like the depth of the learning problem. It's not just sort of like reasoning about like what someone reasonable would do in a social situation. It's like figuring out the idiosyncratic properties of particular partners, as well as like abstracting away what different people have in common. So I think that we really need our systems to like be able to, like, this is how people handle the problem of social like cognition, right? Like people can't get away with just doing like game theoretic reasoning. They have to adapt. And like, I think that our approaches in engineering kind of need to take inspiration from that, I guess. Okay, that's my like last kind of pitch. So yeah, I guess we have a few minutes for some more questions.
Okay, great. Thank you so much, Robert. That was fantastic. I have so many thoughts and questions, but I will defer. We can talk about those later. Do other people have things they want to ask? Okay, maybe I'll kick it off. So it seems like there is like some incentive over this process to reduce the number of utterances and have a more and more concise way of describing something. Do you think that's because it's like just more efficient in order to actually map between the two things? And if so, how do I consider that as well in my cost function? Before we were originally talking about kind of the more utterances, the better. Yeah. And now you're saying that, but over time, it's better to make it more concise.
Yeah. So I actually think that this is a pretty good example of the kind of resource rationality thing, at least in the sense of like, so we have a model of this reduction, like a rational model of this reduction. And the basic idea is that when you have a lot of uncertainty, you would like to be efficient in the same way that like, basically in the same way that you would like to get away with less perspective taking, right? It's like kind of all other things being equal, it would be better to do something cheaper. But like you have enough uncertainty at the beginning over whether a cheap thing would be successful that you kind of like, it's worth kind of taking more cost hit, right? To kind of like hedge against that problem. So it's basically like in the same way that like when you like basically like before you knew that your partner was going to be uncooperative and like not take theory of mind into accounts in that adaptation case, right? It was like rational to dial down your perspective taking a little bit because you could get away with it. But like you incur more cost in order to solve that problem. So basically here, basically the theory is that like at the beginning, people are incurring more cost in order to like achieve success. And then as they become more confident and like learn about their partner, they're able to achieve the same success with shorter utterances. So it's
interesting. I feel like sometimes for me, when I'm trying, even when I assume that the other person knows nothing, but when I'm trying to explain a totally new idea that I had to someone else, I have this tension between trying to ramble and say as much as possible about that idea to get all the information across versus trying to like say the most concise thing possible, less for my own efficiency of how many words I say and more for me trying to map how efficiently they'll be able to decode that, I guess.
Yeah. Right. So I guess this, like,
I don't know how that plays in.
No, that's a really good observation. And I think that, like, you know, this relies a little bit on the notion of like redundancy in the signal. So, you know, if you think that, like, adding additional words will actually confuse them, then it's like not actually redundant in the signal. It's actually
right.
like,
Am I strengthening the signal or just adding noise? That's an interesting way of putting it.
so I think that here the assumption is that like people are able to, like, you know, when they're saying something like leaning toward the left, right? That's like an additional detail that may help resolve some confusion over like what a wavy tube, like wavy tube guy could describe a lot of things, right? Like that, you know, like there's all kinds of shapes that wavy tube guys take. And this is like narrowing it down to being like, it's not just that, it's also leaning toward the left. So the idea is like, this is hopefully not like rambling or sort of like adding noise. It's sort of like adding an independently decodable signal. So it sort of relies on the notion of compositionality, like working. Where like each of these things on their own is like clear. It's just like when you combine them together, they get better. Like you need it to be kind of like a product of experts.
Right. Yeah, we need to like SVD on the. That's funny. Okay. Other questions?
I was kind of wondering on, so a lot of the talk seems centered on like the speaker giving more information, but in, I guess, areas where like maybe data is sparse or you can't dissipate more information, are there any studies on like modeling kind of the listener's perspective and maybe like how the listener can tease out more information when the speaker is limited?
That is a great question. So actually, I think that does come back to this sort of like this kind of division of labor idea. So I think there's a few things you can say about that. One of them is like questions, like basically dialogue is bidirectional. So I do have a project right now looking at sort of like in these reference game settings, there's like things listeners can do when they're confused that aren't just kind of like make a mistake, right? So it's like, if I'm a listener and you gave me a kind of confusing description, maybe because you're, you know, sparse, you know, like your learning was sparse and you don't really have a good way to describe it for me and like, or whatever. I can kind of cooperate as a listener, right? I can say like, do you mean the one with blah, 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 right? Or I can say like, could you be more specific? I could say like, does it have a horse in it? You know, there's like all kinds of questions that I can ask back that sort of like is, yeah, basically you can have a model of question asking that's sort of in terms of information gain, right? That's sort of trying to elicit more specific information according to like what you as a listener need to like solve your problem, right? So it's like often someone will like ramble for a long time because they think one thing is relevant, but actually something else is relevant. And then like asking a question can sort of like inform, like, yeah, I actually have several things on question asking, but yeah, so we could talk more about that. But I think that is like an important part of the story.
Oh, and then one more quick thing, kind of what about like limiting, so thinking more from the perspective of like machines, what about like further limiting like both people to like a very, very constrained set, so that like your query is very like, it's very constrained, and the thing you're trying to describe or communicate is very outside the set. Are there any studies done on that, and how potentially you could expand the set with only the things that you have, or and stuff like that?
Yeah. So actually, I may have maybe not in. Oh yeah, I do. Okay, good. Yeah, so we actually did a artificial language task that was kind of an extreme version of that, where basically like everyone's limited to providing one of these nonsense words. That the idea is basically like completely break the prior, like whatever prior people are like bringing in with language, let's just start them from scratch and see like what kind of communication protocol they form. And this is where pragmatics are actually, so basically we manipulated the environment so that for some pairs, they had to make these really fine distinctions between very similar objects, and other pairs didn't. So basically like, you know, they had to distinguish between the different colors, but not like the different shades of blue. And so yeah, predictably that makes it harder. But the kind of interesting result is that the lexicon, the kind of conventions that form are kind of tailored to the environments. So basically the explanation for this is that in that like recursive reasoning model I presented earlier, that's like this idea of pragmatics, of sort of like being informative in the context. So basically if you assume that your partner is like being informative, then if they use a word in this context and you pick this, you can probably assume that that word didn't also mean this, because if it did, they probably wouldn't have said it, right? Like basically if like your partner, yeah, so basically you can like reason backward about the alternative utterances your partner could have said and didn't say. And that allows you to kind of like adapt to the like demands of the task that you're doing. So I think that that's kind of like maybe the closest to the kind of thing you're describing, where it's like very constrained. These are only one word utterances. People can't really give more information, and they just kind of like need to figure out the best conventions they can use with that set of things. And it turns out that like, yeah, they form these like abstractions, right? Like if you're in this environment, you narrow down very, this is kind of like you're a medical doctor or something, and you really need to like distinguish between like this strain and that strain of a particular bacterium, right? And then like for the rest of us, we're like not in an environment where we need to make those distinctions, so we can just talk about like very common language, like, you know, the flu or whatever, right?
Cool.
I had the same thought, Nikhil. I was thinking like, usually we think of the bigger the search space, the better. You can just only optimize even better when you have more of the domain. But in this case, I could see it by restricting the search space and restrict, like if in the wavy man guy, there was also only like a set of 20 words that you were allowed to click from describe it. And I knew also what those 20 words were. I don't know whether it would be more or less efficient than just doing like free style sentences. Yeah, that was really interesting.
I think it's cool.
I think that that's another insight, is that like the stringing multiple word things together only works when you have some compositionality and like some prior over the things. Basically, like if each individual is completely meaningless, there's no reason to.
Right, matching meaningless words to meaningless pictures. Yeah. That was fantastic, Robert. Thank you so much for taking the time and answering all of our questions.
It's good to meet all of you. Yeah, and please, reach out yeah, I'm happy to talk more.
Okay, great. Let me pause the recording. One thing, since I'm